Good morning, everybody. Welcome to the Discrete Math live session. I hope all of you are able to view the video and my voice is audible. Please drop a message on chat if you are unable to hear or view, or if you have any trouble with the logistics part. So, hearty welcome to the live session. So here we'll be addressing a few questions of yours and give an overall view of the Discrete Math course, how it has gone through. So thank you everyone for joining the course. It has been a great journey from Jan till today. And now let me start with DMWiki as the first thing. Thank you everybody for joining DMWiki. I hope you all enjoyed editing over there, writing your content, discussing, posting questions, answering others' questions, contributing to the assignment solutions, and whatnot. So basically, why did we do DMWiki? Let me just focus on that part right now. It is a platform where learners can collaborate. We all wanted you to get together, mingle, develop your notes. See, if one of you develop your notes, it will be just with you in your notebook at your place. But then if you want it to be seen to everybody and you want to get access to others' notes as well, DMWiki is the right place. So we created DMWiki with the intention of helping all of you so that all of you benefit. And I hope all of you have actually benefited from it. So the Supernote section, basically we used to, on every Monday, we used to make it live along with the course content. And then throughout the week, you guys used to really enthusiastically write everything and then edit others' notes. And I've seen like a few of you like really passionate about writing content over there. Coming to the discussions, so the Google groups, whatever was there, we were answering your questions by directing you to the discussion page of every week, just to involve you with the discussions on DMWiki, because it is you can view others' questions, answers in a more like it's easy to access questions on DMWiki more better than Google Groups. And then assignment solutions, it was a great benefit, I hope, to you all, because at the end of the deadline, you'll be waiting for the solutions. And I know how it feels when you want to know an answer and it is not available anywhere. So a few of you were really passionate enough to give the solutions to the assignment. Thank you so much for that. It has been a great help. And then that was pretty much it with the DMWiki. I see most of you asking questions about gate preparations and giving gate exam. So we have designed Discrete Math course in such a way that it covers most of the topics of gate, basically counting questions, functions, relations, graph theory, and groups. So we have picked the topics very keeping gate in mind, as well as doing justice to the knowledge that we pass on. So we have strike the balance between both. And I feel if you learn the concepts taught in the course thoroughly, that should really suffice. And the most important thing for such exams is, if you know the concepts well, then and practicing a lot of questions, that must really help you. So in the same connection, we had on the course homepage, we had mentioned the two reference books, Grimaldi and Kenneth Rosen. So the practice questions which are there behind the chapters of each of both of these books, they are really helpful. A lot of questions are there. You can solve each one of them, and then that will be a lot of practice for you. And as well, the assignment questions that we give in every week, we have framed it covering most of the topics of the course. So solving such questions should also help, but we cannot really comment upon how easy or tough how easy or tough questions you should focus on, which will benefit gate exam. So the moral of the story is, practice a lot of questions, refer the book and the videos. You can always get the video even after the course is over on nptel.ac.in. You can download videos over there, and you will have access to those videos there. Assignment questions, I suggest you write it down somewhere and keep, so that you can access it even later. It will be a good practice for gate exam. And coming to the NPTEL exam, which is scheduled on 27th and 28th, I hope all of you were able to download your hall ticket, although some of you were telling you weren't able to or the page wasn't up. So I hope all of you were able to download the hall ticket. So for NPTEL exam, again, I suggest practice all the assignment questions. Focus on understanding the concepts well. That is more important than solving questions. Also, yes, solving questions is important. It comes as a secondary thing. First is knowing the concepts really well. So as I said, assignment questions should help, and learning the concepts from Grimaldi and Rosen, that should be good enough. Coming to the internships, which we stated on the course homepage, as well as I think NPTEL website and the web page, the first page of DM Wiki. That is mainly the one which is given by NPTEL is different from the one which is written on DM Wiki. So let me talk about the NPTEL internship. It will help most of you. So NPTEL internship is the one where it is funded by NPTEL. Students who secure gold elite marks, that is 90% and above in the NPTEL exam, can apply for, are eligible to apply for the internship. So how does this basically go? You get gold elite after your exam, the results are out, and you, if you've secured gold elite, more than 90% marks, you apply through the NPTEL website. I think you will be able to access all the details there. And you can, this is an opportunity for you to intern under your course instructor. So once you apply, the applications go to the course instructor, and the course instructor shortlists based on your credentials and whatever achievements you have, academic achievements and other achievements. The instructor will go through and will shortlist. That's how it works. And please note, it is funded by NPTEL. I think they have different funds for 4 weeks, 6 weeks, and 8 weeks. So these three are the categories. So you can apply once your results are out, and if you have secured gold and elite, gold plus elite, that is more than 90 marks. So other than that, the one which we gave, that is on DM Wiki, we had announced that we will give internships for those who edit extensively over there. That is still on. Though the institute internships at IIT Ropar are starting on May 15th, you can as well apply through the NPTEL internships, because most of you got requests. We sent it late, and most of you were telling that the web page is not working, IIT Ropar Institute page is not working. So please don't panic. You can always wait till your results are out and apply through the NPTEL internships. We will always shortlist and call you if you are eligible. Moving on to some of the questions which we had received. Some of you had asked about Catalan numbers and all. So basically, Catalan numbers are the number of ways in which we can move from 0, 0 to n, without crossing the diagonal. So I think we had spent a good amount of time in week 1 talking about Catalan numbers. It is quite an interesting and important topic, in the sense that particularly when you go from 0, 0 to n, the thing to be kept in mind is you should not cross the diagonal. You should not trespass the diagonal. There is a straight diagonal which goes from 0, 0 to n, so you should not directly, you should basically, we want all those paths which go from 0, 0 to n, without crossing the diagonal. So the method which we followed, I'll not go into all the details. I can just give a broad view. So basically, we are interested in those ways. So what we do is we consider all possible paths of going from 0, 0 to n, n. This will include everything, the ones which cross the diagonal and the ones which don't. So with this in mind, now we will subtract those paths which actually cross the diagonal. So what remains are those paths which actually do not cross the diagonal. You see, if you take some particular right, up and up, gone, you are trespassing the diagonal. So what we do is we consider only those paths. We considered all paths and then subtracted those paths which cross the diagonal. So the remaining ones are those which do not cross the diagonal, right? And the number of paths will be like, to go from 0, 0 to n, that this precisely will answer the question. And in particular, we had also spoken about the examples or the similar Catalan numbers where we see in other places, parenthesis, and number of valid parenthesis. If you have, let's say, we consider a parenthesis to be valid if it is open and closed. If you have open, open, and then closed, then it is considered to be invalid, right? So one closed, one open, and one closed should be one valid parenthesis. So how many, like, n number of parentheses will be one, one, two. Number of ways of having valid parenthesis or grouping will be 1, 1, 2, 5, 14, etc. The same holds true with handshakes, where you have two n people sitting across a table and you want handshakes without crossing each other. Like I think you have seen that video. So if there are four people, so you have two and two. So the number of ways in which they can shake their hands without crossing is two ways. So this is how it goes. Basically, the idea is similar to the one where you talk about crossing, going from 0, 0 to n, n without crossing the diagonal. So this is it with Catalan numbers. Now moving on, I think most of you asked about internships and gate preparations and all. I have covered most of it by now. Let me just give an overview of the entire course. So we focused mainly on counting because counting is the crux of discrete math. We always speak about counting in functions. We speak about counting we have advanced counting as the entire, I think, second half of the course was mainly focused on advanced counting, where we speak about generating functions, principle of inclusion, exclusion, and recurrence. And initially, of course, we spoke about the counting chapter. The very first chapter was counting, where we had focused on some of this rule of sum, rule of product, and binomial theorem, and so on. So the entire discrete math in a nutshell will be the heart of it lies at counting chapter. If you know counting, you can be confident with most of the other chapters. Of course, graph theory is slightly secluded from this section, but then counting covers most of it. So set theory, if you know set theory really well, that will help you to, again, understand the concepts of principle of inclusion, exclusion, and on a whole, functions, relations, everything. So logic, basically, the main idea is it comes in the third week. So logic mainly gives you the proof techniques and some logical deductions, what we can do. It is very important when you prove mathematical theorems rigorously to know the logic. So when you actually want to prove mathematical theorems, if you use logical deductions or techniques, it'll actually be hidden. The moment you use it, you bring in abstraction or rigor over there. The next chapter being relations, I think it is the foundation for the chapter functions. So you say two sets are related if there is a rule which any two elements follow. So this is the idea of the relations chapter. We have not covered a lot of advanced relations where we speak about, if some of you are interested, you can go through Hasse diagrams, topological sorting, and 2-3 theorems in Grimaldi book there. We have not covered all of those because it is slightly advanced and it's beyond the scope of the 30-hour course. So moving on to functions. The idea of including functions is everything in computer science almost lies on the idea of functions. So you give an output, it gets processed, and you have an input, it gets processed, and you get an output. So I think the important part of functions is Stirling numbers. We have covered that. That is number of functions from a set of m elements to a set of n elements divided by n factorial. So you just have to keep that in mind. Stirling numbers is slightly advanced. And then moving on to MIPHP. Induction is again one such topic where things are slightly subtle over there. You have to understand the trick involved, and then using induction will really help you prove stuff. And a pigeonhole principle is very simple that way. The idea behind pigeonhole principle is very simple. You have m pigeons and n pigeonholes. If the number of pigeons are greater than the number of pigeonholes, then you have two pigeons or more than one pigeon sitting in a in sitting in one single pigeonhole. So again, this is another kind of proof technique. You actually speaking, MI and PHP do not lie as very independent concepts. They form the prerequisite to prove stuff. So you can use MI and PHP in your concepts like functions and counting and like that. I think we have also dealt with proofs where we use PHP in functions chapter, or rather, if we have not done, you can also take a look at it. We use PHP to prove the number of function, the number of, let me just recall, if there is a domain and a codomain, then what is the cardinality, the condition for cardinality for a function to be really valid, like 1 1 and on 2. So we use PHP there. If we haven't covered it, I do not really remember, you can just take a look at it. Then moving on to graph theory, it forms an important concept in computer science. Um, Graph theory is the basic of a lot of networks which people deal with. You have nodes and edges, and we have covered almost everything in graph theory, like Hamiltonian, Eulerian paths. When is this graph set to be Hamiltonian? So the theorems covered, the Dirac's and the Orr's theorem, they are very important. They involve a lot of rigor, but then we have done it very neatly, I must say. Moving on to generating functions, it forms the advanced counting part. So exponential generating function was put in the last week because we thought that you must have some sort of maturity to understand exponential generating functions, and that's true with all the concepts which came in week 12, uh, because we had designed it in such a way that we thought that by the end of the course, like by the time you finish 11 weeks, you would have gained some maturity with the math and the concepts involved. So by week 12, you will be able to understand the integrities of all these concepts which are taught in week 12, which includes advanced exponential generating functions and some advanced graph theory, chromatic polynomial and stuff. Again, in chromatic polynomial, let me just jump over there now. We are seeing in how many ways we can color. Counting comes even there. I think we had mentioned why we represent it in the form of a polynomial. It's quite important. Uh, Moving on to the next chapter, it is principle of inclusion and exclusion. The main idea, principle of inclusion and exclusion is basically as we have covered, a set of some 20-25 problems. The moment you do that, you will be able to realize that the concept, the main idea here is just overcounting and undercounting. You have to strike the right balance when you overcount and undercount. So when you do that, I think you have learned PIE chapter. So when you deal with 3 sets or 4 sets, you have to be really careful on the intersections and the unions, and that will solve the problem. After PIE, we had done After PIE, we moved to the last week, that is week 12, where we did group theory as well. Group theory covers slightly, we covered very few topics. We basically defined what is a group, an abelian group, and that's it. So you can always refer several other books for group theory. We have covered just little part of it, which we just wanted you to give a touch of it, and hence that was with group theory. Um, I would like to hand over the session now to